Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Ahmed Mumtaz Mustahsin, your teacher for CSC 141 Introduction to Computer Programming. Students, in the last lecture we have started chapter number 11, and I have already explained it to you that this chapter I have picked up from your reference book, See How to Program by Detail in Detail, chapter number 11. We have discussed already the sequential file processing, and we can now start with the random file. And I just quickly go through the explanation that I have provided at the end of my last lecture regarding the random access file. A random access file is a file that contains the record of fixed size. So if we can fix the size of the record, then we can create a file. We can create a file for, let's say, 1000 records, or the file may contain 500 records, 600 records, 800 records, or even 1000 records. So we can put the data randomly into this record, not necessarily that we need to create this file sequentially. So we can keep on asking the users, and the users can keep on coming into the organization, suppose in a bank, and the user accounts may be created. But the good point is that in the beginning we can fix the size of the record. If we can fix the size of the record, then we can jump up directly to any particular record. We can jump up to record number, let's say 67. If there are records, 100 records, so we can jump up to any number of record. How can we jump that? We can jump that because we know the size of the one record. The first record starts from the 0. The second record is at the next block, and the size of the block could be the size of your record. So if you want to jump up to the record number 7, so what you will do, you will say that it will be 7 minus 1, because first record had been stored at the 0 location. 7 minus 1 multiplied by the size of the record. Just like in the array elements, we can pick up any element. So in this way, now we are free to update the record, we are free to delete a record, we are free to modify the record, and even we can access a record directly, and we are not bound to access any record through going through the sequence of all the records. So if we want to access this particular record, we can directly jump up from any point to the start of this block, and we can just read that particular record. And in the sequential file, we need to go through each and every record sequentially, then and only then we can reach to our desired record. Okay, so creating a random access file. So data in the random access file is unformatted. I'll just also explain in the last lecture that this data is stored in the raw bytes. Raw bytes mean in its own format, in the format that is known by the compiler, that is known by the system, that is the directives of the operating system, how this data should be stored, and what should be the size of the floating data, and what should be the internal representation of the floating data, how much bits are there for the Manthisa part, and how many bits are there for the exponential part. Similarly, the system has already defined that what should be the size of the integer data, whether it is a 4 byte or whether it is a 2 bytes. So the data is in the binary form. If the data is in the binary form, it is in the raw form, and the decoding of the data is not so simple. So from the user point of view, or human point of view, you cannot directly read the data from your naked eye. You need the assistance of the system, and the system will decode it and can print it for you. Okay, so let's see what are the facilities for the input-output functions available in our standard library, just like the functions that we use for fgetS, fputS. Here we have got the facilities of fwrite and fread. This fwrite function transfers bytes from a location in the memory to a file. Okay, obviously we can just write the data into the memory, and then the system will pick up the information from the memory and transfer it to that particular device where you have created the data. Similarly, for fread, you can transfer bytes from a file to a location in the memory, and then using your program you can use the format specifiers and the information available to you regarding that particular file. You can just decode it and display it. So the format of this fwrite is, number one, the structure of the data. It could be structure itself, it could be array, it could be one single element, but usually we store it in the form of a block of data. Usually we write down one time the one block or one buffer of data is written. Read and write is performed because it is optimized form of reading and writing it. If you are reading and writing it character by character, then it becomes very difficult for the system. Why? We can do that in the sequential file. Why not in this random file? The answer is that we are requesting the services of the operating system, and it's a long sequence to find out the descriptor, then the address, then go to the operating system table from which file control block it picks up the address, then it invokes the device driver because we add the complexity of the devices. So we are required to use the device driver of the tape where you want to create a file, or the disk where you want to create the file. So basically it involves a lot of services. So after getting a lot of services, you just want to read one byte, so it is not efficient. That's why we usually perform block by block, and this block by block writing can be done with the help of fwrite. So the first one, we could have a block, and this block could be over structure, this block could be over array, this block could be over one complete record. Then we should also know the size of this block also. Size of this block, we can use size of operator, and we have already seen that. We can just easily find out whatever data type we put it inside. It could be integer, double, float, or it could be array, or even it could be a structure. So you can put in the structure name here, and then you can find out the size of, and then it should be able to read and write the data. Then number one, this one is basically for array number of elements to transfer, means how many times this block of data you are going to write that. I will explain it later on, because if it is an array, you can write down, you have an array of record, then you can write down this block in one go. So this is the number of times that you are going to write that block, means the data that you have provided, you can just have a control of it. I'll explain it later on with the help of an example. And myPTR, basically myPTR is a file to transfer the data to or from. Okay. Structure. Writing structures is just like you might have defined, as I said, you can use directly a structure here also. That's the only change with the help of, with the reference to the previous example here. There it was int, and I said that you can even use the structure, my structure. And then once again you can use the size of operator. To write several array elements, you can do that by using this number here, a pointer to array as the first argument. You can just use it, or you can number of elements to write as a third argument. The first argument is the pointer to a structure, second argument could be the size, then the number of time you are going to write down, and finally you can have the pointer to that particular file. So let's take an example now. This time we have defined a client data structure here, because we would like to write down in the form of block by block. Okay, let us see. structure client data, int account number, that is the account number is an integer. This time we have, instead of using the name, we have split up the last name and the first name, and be careful that we have just used the last name 15 character and first name 10 character, then the account balance. And this is the structure that we have defined globally in our program. Then in the program we can just use this structure client data blank client. Okay, that is something that I would like to explain. This blank client that you can always create. You can always create a blank client to create the whole file. You can create a file that may contain 100 records, but in that case you are required to provide a complete structure. This structure might be empty. For example, this integer account number could be initialized to 0. This last name is a null character, could be initialized to null. The first name could be initialized to null. The floating point could be initialized to 0.0. Even if you don't put data in this client structure, you can initialize this client structure, each and every member of the client, to an initial value equal to 0. In this way you can determine the size of one complete record. Then you can define the file pointer. This is C pointer, pointer to a file. And next, open up this file. We want to open a file to write this data. First of all, we would like to create a file, and then we will like to read that particular file. So this time we are not using W, but we are using WB, because this is going to be a binary file, and this is going to be a random access file, which the characteristic is that it is a binary file, so that's why we should use WB here. The same thing if it is null, that the file cannot be opened, no space or something, some other reason. Otherwise, if you can open it up. Now this is something very interesting. For I is equal to 1, I is less than equal to 100, I plus plus, we are outputting 100 blank records. So basically we are creating a blank structure of 100 records, and that will be a blank file. But this blank file will be a template, will be a complete template of 100 records. But the difference is that each and every record has been initialized to 0 value, but the structure is created. The beauty of this particular way of creating the file is that the total size of the file is available. The total, each and every record structure has been defined. The record structures has also been defined. The combinations of the record structure has also been defined. And then you can just access any record, and then you can access within that particular record. So with this particular for loop, we can call this fwrite 100 times, means writing 100 blocks, and we can provide the address of this structure. Size of the structure will be computed by the system itself using the size of operator. You are writing one record at a time, and then you can just write it in. Maybe you should try to create it by just one fwrite, and writing here instead of 1, you can write it here 100. So the record should be created for the 100 record. That we will experiment it at the time we will be doing the demonstration. Then we can just close the file. The file has been closed. We have done nothing. We have simply opened the file, created a template, created a structure, and we can close the file. Then writing data randomly to a random access file. We have closed the file after creating the structure. Now we want to write down into the file randomly, because it's a random access file. So for that purpose we need to use something which is called fseek. What is fseek? Fseek is basically a position of a pointer to a specific record, to a specific position of the record. It could be record number 47, record number 33, record number 38, or it has got some other very interesting predefined features that I explain you right now. This is a pointer that points to a file. Fseek is a pointer to a file, but practically this is not a pointer. This is practically integer offset. integer offset, just like say what example I could code is the example of the array element. So element number 47, just like that you may call it as a pointer, but this is an integer position pointer. 0 is the first location, 1 is the second location, 2 is the third location, and so on. So it's a symbolic constant, specifies where in the file we are reading from. So we need to set our position first, and then we can just read it out. Then there are this symbolic constant. This is the, by the way, the structure of this, the prototype of this fseek function. System calls fseek pointer. Pointer means which file you are going to read, offset which record you are going to read or write, and symbolic constant. And these symbolic constants are basically this seek set, seek current, seek end. Seek starts at the beginning of the file, seek starts at the current location of the file, and seek start at the end of the file. Seek start at the end of the file means you want to take the seek to the end of the file. You might require it in order to close the file or whatever reason you want to do, or maybe you want to read backward. So let us write down the data in the file that we have created. We have created an empty structure, and now we are required to writing the data into that particular structure. That we can always do with the by using the same structure that we have defined by creating the file. And then now structure client, this one we have again initialized it, and now we can just open up the file. This time we are opening a file in the form of RB plus. Do you remember what does RB plus mean? First of all, RB is basically a mode of file in which you are going to open the file. So you can the mode could be the read a file, or mode could be write into a file. So here the mode is read to a binary file, but plus indicate means that you can read it and write it simultaneously. You want to open up a file where you can perform the reading and where you can also perform the writing. If you do not find the file, you can, it will system might generate an error message. Okay, we can ask the user enter account number. The user will enter account number from 1 to 100, and to end we can ask that to end the input, the user may enter, for example, 0, or for anything that you can just describe to that particular user. So now we can just we can read out the information into the client's dot account number. First of all, we will read the account number, and then we can say that while the client account number is not equal to 0, it's mean that the loop should continue to read the data. It will keep on reading the data until we enter an account number 0. Okay, when we enter an account number 0, we can just terminate that. So enter last name, first name, and balance. For what? For the account number that you have already read it outside. Then you will read the from std in, because you are providing the data from the keyboard. Now instead of using a scanf function, we are using fscanf function to create a symmetry between read and write, because we would like to write it with the help of printf, and we would also write to read it from the file next time when we are going to update it. So we are reading it from this using the function fscanf, so we are bound to provide the input stream, and input stream, standard input stream is stdin. Then the format specifiers for these three, last name for first name and for the balance account. Then we can read client dot last name, client dot first name, and this one. For this we have not used ampersand sign, but for balance we have used the ampersand sign. Why? I think you know the answer. Okay, seek position in the file user specified record. So first of all, we need to set the pointer from where we are just going to read or we are just going to write the data. For that purpose, we need a pointer. Then the second point is the client account number -1. वो formula जो मैं भी आपको बता रहा था कि for 7 you need 6 multiplied by the size of the file, because the first record starts from 0. So this is the client account number -1 multiplied by the size of the record, and the size of the record we can find out with the help of size of operator, structure client data, and then seek set. Seek set basically sets the pointer to that particular record so that we can carry out read or write function from that position. So this is something that you are required to do, that we haven't done it in the sequential file, because in the sequential file we were supposed to write down the information just one after the other. So we could just because we didn't have the concept of the record there, we just have the stream. So the system automatically saves the address of the next byte of the stream when we read the previous set of bytes in the form of the record that we have created by ourselves. So वहाँ पर हमें इसको seek करने की, अपने pointer की position adjust करने की ज़रूरत नहीं पड़ी. Then we can write at the specified position, where because we have already seek that position, then we can write with the help of this again the address of the structure. Then we can have the size that we can always pick it up. Then we can have the one record at a time and the file pointer, where the operating system will facilitate us to write to that particular file. Then we can just ask another account number, read that account number, and then you can go back here while loop. If unless until you are not going to enter 0, you will keep on entering the data. You can enter the data account balance in positive, account balance in negative, account balance equal to 0, and that will help us in carrying out and manipulating the file later on when we will go through it and we process that particular file. So once we complete the job, then we can just close the file. This is the same, just like the sequential file. In the same format, we can close the pointer here and return 0, because we have started integer main, and integer main should, this is int main, and it should return integer value, so it's return 0, indicate the termination of that particular example. So we have created a template file. Then we have used this particular example to put the data into the file at random position, whatever account number the user will provide between 1 to 100, because we have created a file with a provision of 100 records, and then we can just keep on entering the data. In this particular example, we haven't done any check that the record already exists. So if you use the same account number, you will lose the previous information, you will overwrite that information, because the check we haven't carried out in this particular example. But you can do that. If you just want, then you can check whether that particular account number contains maybe some information regarding the first name is not null or the last name is not null. It means that the data is already there. In that case, you can ask the user that record already, this account number has already been issued to some client, your record already exists. So this could be the input. Enter account number from 1 to 100, 0 to end the input, 37, and then you have entered last name, first name, and the account balance. Keep on entering account number 29, last name, first name, account balance, last name, first name, account balance, and you can keep on entering the data one after the other, and you are not bound to enter 100 records. You can enter as many records as you wish to, but should be less than 100. And for every record, there should be a unique account number. Otherwise, in our particular example, we will lose the previous one. And whenever we want to terminate, we can just enter a 0 here. Once we enter a 0, it's mean that our program will terminate. So in this way, we can just open up and create a particular file. So writing data to a random access file means, first of all, we use a pointer. that is the file pointer that is available into the memory of the computer. Using that pointer, the operating system takes us to the start of the file. Once we are at the start of the file, we open the file. By default, we are in the beginning of the file. Then we use fseek operator. That means the pointer that points out to that particular record. And you can see that this box size of equal size. Similarly, these are boxes are all of equal size. And we said that this random access file contains a fixed number of bytes, mean the standard size or whatever the size, mean the same size, not standard size, same size of every record. And that help us to seek that position of any specified record in our file. So if we want to go to the byte number 5 or the record number 5, and we can easily do it with the help of very simple formula, and then we can just find out the position. And with the help of that, the seek pointer takes us to that particular position of the record, and then we can carry out the updation of the data, and we can perform the updation into the record. So now we have created a file, we have placed the data into the file. Now we want to see how this data has been stored, and we want to read it out. Since I said that the human being cannot read it out, but if you see it from just a dump, then you will not be able to decode it. But if you read it out with the help of this professional way, through which you can just put the record and place it up according to certain format, you should be able to understand the data. So read a specified number of bytes from the file into the memory. So we use fread function. Same, you will read, because you are going to read record by record, one record by one record. So for that purpose, you need to provide the address, then you can provide the size of the data, and then you need to provide the pointer. So you can provide the pointer to an array or pointer to a structure. Then you can indicate the number of elements that you are going to read. Then to read a multiple element, specify the third argument. That is the first, that is the second, that is the third. So if you just want to read, but for that purpose you need to provide the structure also. You need to provide the buffer size there, because the operating system will read the multiple structure file, but then you should have provided that buffer size or that structure where the system should be able to put that record. So if you want to read all 40 records in one go or all 100 records in one go, then you are bound to provide the array of structures here, the address of the array of structure, so that all records could be read in one go. But in this particular example, we are reading it one by one, so that we may understand that what is the concept. So here we go. We just going to read the data that from the random access file. So we can create this particular file here. Okay. Then a file pointer cfptr pointing to a file and structure of client data. This is initialized. Okay. Just to initialize, to give the initial value to this client structure, we can initialize it initially, so that if the data is read and not properly read, you should have some initialized value already from there. So we can open up the file. In this time we are not we have just opened up for the reading only, not writing it. So we can RB, last time it was RB plus. So similarly now here we go. I said that yes, this binary data you should be able to see that. So how can you see that? You can just use your printf expertise, and you can say percent format specifier -6s. What does it mean, -6s? 6s means 6 character, minus mean justified from the left side of the screen. After completing this 6 character, then -16s for the next. So next data you are going to read it in the 16, again it is the left justified. Then the third -11s, %s, then 10s, and so on. So basically these are 1, 2, 3, 4 arguments, and maybe this is the fourth argument. Then yes, for This is 10s for this one, this is for this one, this is for this one. So 1, 2, 3 and 4. And 4 arguments are, this is the title account, 1, 2, 3, 4. So this is just for the title. Okay, then we can just start reading it, read address, size of the data one by one, and you will keep on reading it, that if the client dot account number is not equal to 0, means the end of the file, you will have account number should be equal to 0. So just you will write down whatever information you have read it here, you will write it, then you will read the next account. So until there is a next, you can just keep on reading the data. But here, what we are doing here, we are reading it from the file from the beginning, because by default it starts from the 0 and we are reading it. So you can see that we have not done fseek. This fseek by default, when you open the file, put the pointer in the beginning of the file. So here in this particular example, the system is reading record by record sequentially unless until you go to the account number 0, that we use it to finish the last record. So in this way the system will keep on reading it. So you can read the data from random access file sequentially. Okay, but in the sequential access file we can only perform the sequential access, not the random access. But in the random access file you can create the file, you can read the record randomly, or even you can read the record sequentially. Both are possible. So in this particular example we are not using seek, but once you read the first record, the seek will automatically come up to the pointer will automatically come up to the second record. Then you read the second, then the third, then the fourth, and you keep on reading it until you encounter an account number that contains 0. Okay, so that's why no seek is present here. So you will read 29, it's the last name, first name. This was the first format specified that I explained it to you, and then this is the last name, first name, and then the account balance of all the clients you have. And this should be the data that you have already created, not in this program but in the previous program. Okay, now students, we have learned a lot of concepts of the random access file, the sequential file. So let us take up a case study. This case study is very interesting case study that I will also be demonstrating during the hands-on demo session, but here I would like to just explain it to you. That could be a good way of revising the concept, because what we are going to do in this program, we will demonstrate using the random access files to achieve instant access processing of bank's account information. So you can consider it as a professional bank account program or the facility where you can just update the existing account, you can add a new account, you can delete an account, and you can store a formatted listing of all accounts in a text file. Means you can create a transaction file also. You can retrieve the information from the stored data into the file, and you can update the existing data. Means you can receive the check, find out the balance there, make the payment. You may receive the payments, find out the previous balance there, add the data, add the amount that the user want to deposit into their bank. So basically this particular program is providing you the online transaction processing carried out by a bank on any banking counter. So you can do it now because you have learned each and every concept of this transaction processing. So we can start with this program that reads a random access file sequentially, update the data already written to the file, and create a new data to be placed in the file, and delete the data previously in the file. These all functions it should be able to do. So first of all, the client data structure we are going to define, and this is that same client data structure that we have used in the previous examples, that contains the account number, last name, first name, and the account balance. We have kept it very simple, the barest minimum information in this example, so that we could demonstrate a good use of this particular facility. So prototype of the function that we are going to use in this particular example are first of reading the choice from the user, that what type of activity you are going to perform, then to create a file, to create a text file for reading in future. So you can create a transaction file that you want to use it or print it out onto a printer maybe, and this text file, if it is available, then you can simply use this standard print command and print the whole file for the printer also. So you can update the record, you can just add a new record, you may able to delete a record. These are all prototype declaration of the functions, and almost all the functions, these 4 functions, uses the pointer to file, okay. Basically this is a file descriptor which is a pointer to a file, and this descriptor has already been defined in the header file. So if you might be worried that we haven't defined this file descriptor, how the system has brought it, so it has already been defined and available in stdio.h. So we have simply included stdio.h. It's mean this declaration of this file data structure is already there. If you want to see what type of information it contains, you can always, because this is a readable file, stdio.h is a readable file, you can just open it up, you can just type it, or you can just display it, and you can find how different structures are defined and facilitated that are the facilitation provided in our programming environment. Okay, so let's start with this credit.dat file pointer and the choice. So we can open up the file. This is the same sequence of instruction that we have used in the previous example, and you know that we can open up a file for read and write both. That's why we are using this plus sign. If it is null, then the file cannot be opened, otherwise the file is there for our read and write. Then we can just read a choice here, and we can have a choice up to 5, and then we can just test the choice, and we can have a choice case 1, case 2, case 3, 4, 5, and then we can just close and return. So what is this case mean? Case 1 may we will create a text file, so we need to provide the menu somewhere, and I think I might have skipped that if the menu has not been provided. So I think there should be the menu first to carry out the different activities for before having this choice of reading here. So I think there should be the display of some menu which is not here yet. Okay, so we'll see that file is open while choice is equal to enter choice is not equal to 5. So we can have a choice case 1, so text file, break, case 2, case 3, case 4, case 5, file close and return. Okay, this is the text file that will write pointer, that will the file is opened up with the pointer here. We have created this structure, empty structure, and then we have opened the file here in the W mode, means write mode, and then here we can just after going through it, after opening it, we can just say that rewind read pointer, so that if since you are in the scheme where the user may use it multiple times, so obviously you need to rewind it and set the pointer in the beginning. Then fprintf, this use the pointer and use these format specifiers in order to write it into the file. So you are writing it into the file. Since you are writing a text file, so you can always put the headers also, because this is the not the structure of the binary file that you have created. You are creating a new file, and that new file could be a sequential file, and this sequential file you are just use it just like your screen. That's why you are putting the account title in ACCT you may write down complete account, last name, first name, balance. So these are just like the headings, you use it on the screen. So why not end of the file? So it means that you are going to read the whole file sequentially, and this time you are going to whole file sequentially, which is the random access file. So copy all records from random access file into a text file. So whatever records you have created, you will keep on reading it. So if the client number is not equal to 0, so it will just read it and put it into the file according to the format under different columns with the controlled format and specification. Mind it, this time you are reading a binary file, printing it into a text file through a controlled format specifier, so that you should be able to read it. And then you can say client account number, client last name, first name, and balance, and then you can just, after that you can close the file. Update record, you will once again, the file has already been opened, so we have initialized the account here. Then we can say enter account number, that which you want to update. So you will enter the account number here. First of all here, because this time we are reading randomly, because the user has entered any specified number. The user might have given you some number, that this is a number from where I want to read the data. So it's mean that you have to provide that account number, so you are going to access the data randomly. So you will provide the account number and you are going to access randomly. If you are going to access randomly, then you are going to use the fseek option. Fseek option will put the pointer to that desired position, so that when you will subsequently use the fread statement, it should read the data from the specified location. So it's account -1 multiplied by the size of the structure, and that's why we have initialized the data into the structure, so that the system should also have it, the structure initialized to 0, where you are going to read the data. And this is seek set, and it will set the pointer, and then you can subsequently read it one record at a time. And unless until the pointer is not equal to 0 account number, then you will print out the result. That's why you have not printed it, because if it is account number 0, that has no information. Okay, since we are reading a specified record, and if this record number is not read, it's mean that this account number is not there, because we have not placed the account number into the structure. We have created empty files, and you remember that we have initialized the account number while creating the file to 0, just like this, 0 null null 0.0. So for all those accounts number that have not been utilized, the system will contain account number 0. So if you read an account number 0, it means that the user desired account number is not present into the structure, and then you need to provide that structure also. So if it is 0, then you can display that, otherwise you will read this information and then you have to update it. For update, you can use this information, enter charge for plus or payment for minus, that if the user is going to deposit the amount into the bank, then you will put plus sign with this. It means that amount will be added to the previously stored value. But if the user is drawing the money, then you will use the, from the credit account, then you use the minus to that with the amount. So then you can just read out this transaction payment, and then you can say client.balance is plus, means that you will update this transaction. Client.balance is equal to client.balance plus transaction. So whatever the transaction you will say, will update it and is there. And now you need to update the account also. So this means that the client.account printf on the screen like this, and then fseek pointer here again, and then fwrite, once again you are just writing it. That means you are going to update the file also. This is not the updation. This is the updation that you have carried out to display the information onto the screen. Was move the file pointer to the required file position, and then you can update the data. So you need to put the transaction carried out by the user, but this time not that only single one transaction, but you have to put back the whole data from the memory to the file. Okay, not only just one transaction. Okay, that's very important. Delete an existing record. Once again, it's very simple that you can define the client data with the client structure, and you can initialize it to 0. So delete means that we will just simply put this blank structure over there. Then account number, you will read the account number. User will enter the account number here, enter account number. Seek means you are going to position that because you have to read it. Once you will read this, display error if record does not exist. If the record already contains account number 0, so you will say that users, you are providing the information, you are requesting to delete an account which already does not exist. So otherwise, if the record exists, then you can delete it. How can you delete it? Obviously we have to write it. So for writing it, we will just put account number -1 multiplied by the size, seek set to that position, and then write it. So deleting means writing the initialized data, 0 data into that particular record, means account number 0, first name null, last name null, balance null, means account is deleted. Okay. Add a new record is again same, and you can just use from the ask the user to enter the account number, and then you can have seek position. First of all, you have to read it first, and if the record number is not equal to 0, it's mean that account already exists. So once again, you can ask the user, how should I add an account number which already exists? So if does not exist, then you can just ask the user to provide the user information, the last name, the first name, and the balance from which the user wants to create that particular account. So the client.account number is updated. This information, after picking up the information, once again you will set the pointer to that particular seek position. Why? Because we have just already read it. So why we are putting it back? This is a very interesting question. क्यों? क्योंकि हमने इसको यहाँ पे भी सीख किया था, रिकॉर्ड को रीड किया था, और यहाँ पे once again we are seeking to that particular position. भैया भी एक दफ़ा तो सेट किया. So what's the answer? Can you answer that? But I cannot hear from you, but I know that you know the answer. So for the sake of your curiosity, I can give you the answer as well, that the last time when we have seeked the pointer to that start of that, then we carried out the fread. Once I carried out the fread, then the seek will go to the start of the next record, not the start of this record. And now I have to read the record once again, or I have to write the record over there. So I need to seek, means I cannot just say rewind one, take one record backward and write it from there. I cannot do that. So it's mean that I have to seek it again in order to update the record, and then I can just write it down and update it, and this. So basically this was all the functions, and this is integer enter choice, and this is the enter choice. So I think in the main we should call this enter choice function. Maybe we might have called it, I might have skipped that. जो मैं आपसे कह रहा था, it's not there. Let me see that whether this function has been called or not. Yes, this function has been called. Okay, enter choice, the function has been called here. So it's mean that this menu, once you call this function, so this menu enter choice void is there. So it will say 1 to store formatted text file of account, or then 2 to update account, 3 to update a new account, 4 to delete, 5 to end the program, and then you choice, and then this is end of the function choice. And this could be the example of this particular case study. So we can see that after choosing the option 1, account.text, Okay, so this is the account number, last name, first name, balance, enter account to be updated, plus or minus, you have added plus. So you have selected account number 37 and you now want to update it, and you have added 87.99, it should be added, and then you have entered 3, the account 3, then account number 22. So the last name, first name, you add a new account. So that's it. So we have completed this chapter also, but before I conclude, I would like to show you, I have some time left with me, so I would like to show you how can we create a file. I can just show you how we should be able to create a file into maybe I can have a demonstration of creating a sequential file today, and the next demonstration I will combine with the next topic. So I will use 10-15 minutes for the demonstration of this. Practical exercises that I will be continuing today is I will create a file, and for that purpose I need to, so we start with this visual demonstration, and today let's start creating a new project. New project of it should be an empty project, and name of the project should be file. Always okay, this is a project name, so file processing is the name of the project. Okay, so it should create a project. After a long time we are creating a new project, so the file processing has already been created, and we can just add a file, new item, and we can use C++ file and create sequential file. So I will do a few exercises for creating a file and then for demonstrating the file also. So let's go back to this. In this particular example, we can just open a file in writing, creating a sequential file. This is the example that I've used, client data, and then I can put as could not be opened, then enter the account balance in this. So we can create a file, end of file in this. So the next example is also create a sequential file. Let me see what's the difference between the two files. Okay, this is providing the output, so let me instead of that I will be using this. Let us use this particular /stars. Okay, so I will copy and paste it here. So this time I don't use IOStream because I'm not going to see that. It's just the matter of opening the file, creating a file. So in the next demonstration we'll be using how should we be able to read the file. So let's hope there is no cut paste. This time I've made sure while I was creating this file for you, this file, that I use it as an input. Although I have tried my best, but I'm not sure whether still it has some errors or not. So these are just simple warnings, and we can ignore all these. This is successful. So I've been myself is successful of keeping this file bug free or syntax free. So we can just use a build is okay, debug, start without debugging. Maybe I'll just give you some small demonstration of debugger also, maybe next time or next to next time. So enter an account number, name and balance, enter end of the file to end the input. So first of all I need to enter the account number, let's say 101, Ahmed, name and balance. Balance, let's say 15,000. Then let's say account number 124, and it is let's say Baba, and balance is minus 890 rupees, and then I can enter KA let me see, I can just KHALID, Khalid, and then I can enter, okay, I made a mistake here, so 156, that's why I'm just confused, Khalid, and let's say 100,000 rupees. Then I can have account number 789 of Zafar, and should have minus 8,900, maybe 89,000. Then 786 of Bashir, and should have 1 2 3 4 5 amount. Okay, that should be sufficient. So end of the file, I said it is Control Z, it is Control Z here, so when I press enter it's finished. So we have created a file, and now we would like to read the data from the created file. So for that purpose, reading and printing a sequential access file. So what was the name of the file that we have created here? The name of the file was client.dat. So this file should read from the client.dat. So I'll copy it, Control C, and then I will put it in its place. Okay, Control V. This time it will output, so I would like to put here our old friend system call, system pause, so that we can see the output also. But for that, what happened? One signed integer. The same thing has started. I don't know why it starts. Although I've checked it. Include IOStream. Okay. Unsigned, our old friend error has come back again. Is there any other? Let's hope there is no other error here. And if no other error here, so let's build it. Thanks God. Then run it. So the file that okay, we have just read it from the file, not read it from the keyboard. So it works. So we have been able to create a file, and then we have tried to read the data from the created file, and we have been successful in doing that. Okay, so maybe I can demonstrate you one more example from the file processing, and that example is of reading and printing a sequential file. Both the job I would like to do it simultaneously with the help of this example, so that I would like to do it. Students, you might have noticed that today I'm saving time and a lot of energy, and I'm not saving this because this is the reference book, and you will also find this file from which I am picking up this information. So I'm not saving it here in this example, but it will be a good practice for you while you are carrying out the demonstration or doing the practice. In that case, you should save all the files and then concentrate different concepts that if all the files are there, then and only then you can have a comparison. So आपने मुझे पूरी तरह फॉलो इस तरह नहीं करना, बल्कि you should be saving it also. I'm just saving time, but you should be saving information. So before returning, I'll put here system. Okay, why not? Why not? Return 0, pause. Okay, this is the reason. Okay, good. So this is the reading and printing a sequential file, and this is the example number 11.7, and this is from your reference book. So build, successful, run. So the same file which is reading and writing, okay, simultaneously. So let me see if I could spend few minutes more. Inquiry program. Once again, it is related to this sequential file. So let me take this opportunity and ability to demonstrate it. This was also a program that uses the sequential file, but it's a very, very good comprehensive program, and that has read, write and multiple activities carried out simultaneously. But let us try it also. Today we are a bit fast because we are just going through the motions in the include IO stream and then scanf. At the end, okay, आप कह रहे होंगे कि I'm not explaining it, I'm just showing it that it works and how does it work. But in this particular example, I will take a few minutes to explain each and everything that I've been doing, because this particular example contains everything that I can explain it to you. So we can say we have defined an integer request, then we can define, this is the example that we have been using in our program to create an account that should create account number, account balance and the name. Here is the command that is a pointer to a file, and it has its definition given here in include stdio.h. Okay, here is the command which opens up the file, and we use a function. Okay, you can see that this is file cdcl fopen, this the pointer that returning file that returns function that returns a pointer. So this is the function that we are using it to open up a file client.dat in read format R, and we say that this function will return a pointer to a file, and if this is parenthesis means this function will return to this one, means it will assign a value to this one, and if this non-zero value is assigned to this one, then it is compared with the null. But if the null is there, then CPTR is there, then within the parenthesis you have got null, then null is compared with null, it means it is true that the file has not been opened. But if it contains a non-zero, non-null data, then it will be returned false and it will go to the else state. If it goes to the else state, means that you have opened up the file, and here we can just display a menu here, and this menu basically we say 1 to list account with the 0 balance, 2 to list account with the credit balance, and 3 to list account with the debit balance. Okay, minus K we have already got few accounts, but I'm not sure that we have entered the data with the 0 balance also. Okay, then we can have the user choice of the request and check that while the request is not equal to 4, 4 means end of run. While not is equal to 4, then you can just read this account number, name and balance, and then we can perform the switch that you have already studied. Switch. So if it is 1, then what we have to do? If it is 1, then account with 0 balance will be read, and the system will say it will read the whole file until end of file. Until file end of file CPTR. You remember that I have taught you this function, that this function will return end of file. So it says that until this function does not return you should stay in this loop. Staying in this loop means that if the balance means whatever you have read it, here you have read it, and later on you will read it again within this function also, with this loop also, while loop also. So it says that if the balance is equal to 0, then you print out the name of the person, the account number, name of the person, and the balance. Okay, and here it is closed. So then you read fscanf, you once again read it from the file. We have read it outside, but since now we are in the loop and we would like to remain in this loop, so this while loop starts from here and it is ending. Okay, you can see this highlighted, it is starting at there. So you will keep on reading the data from the loop, and you will keep on writing it, displaying it onto the screen. Okay, so for all, finding out all the clients who have a 0 record, and after that you can break and come out of the switch, and maybe you can next time read the next choice. So if your choice is true that the account credit balance, then balance is less than equal to 0. Once again you have read the data outside, so you have got one record already with you, so you can say that if it is balance is less than 0, you can display the result. But now you will stay in this while loop once again. Here it starts from here, ends at here, and you will keep on reading the data, one after the other until you reach to the last record, and you will print out all the records, all the clients that have the negative credit balance, means they are drawing the credit from the bank or break. Then similarly 100% like this, but just 1 if the balance is greater than 0, then the rest is the same. And then after that you can rewind that, means this is the end of the switch, and then you can just rewind that. Okay, and then read the next request and go back. Okay, so I've explained it, and I hope that you are with me, and let us compile it. Successful. Okay, run it. List accounts with 0 balance, so enter 1. Accounts with 0 balance, as you know that we have not entered any data with 0 balance, so there is no account with 0 balance, but we have entered the data with negative, so there should be at least 2 accounts here with some negative value. Yes, minus 890 rupees and minus 89,000 rupees negative balance. Okay, then we should have some data with positive balance also. This time we will choose option number 3, and we can find out that there are 3 clients who have got the positive data. So we have made only 5 entries into the account. So when you will practice this, you should enter 10, 12 or 20 records, and so that you can have a sufficient data and you can have some good practice and see that how can you do that, and then you can make few changes in this also. And what type of changes you can do that, think about it, and I'll come back with the demonstration of the remaining part. I've not demonstrated I've demonstrated all the applications of the sequential file, demonstration of all sequential file. In the next demonstration session, I will be concentrating on the demo of the random access files. So, or maybe I will just provide some additional tips also for additional topics or the topics that I might have skipped. So I think we can stop here, and that should be sufficient. Okay, it will not stop until I say 4. Choice is 4. If the choice is 4, then end of the program and press enter to continue. Okay, dear students, I hope that you have seen the working, the demonstration. I was a bit fast because just I've gone through in 15 minutes time with all the demonstration of the sequential file creation. Okay, so inshallah फिर मिलेंगे नए lesson के साथ, नए topic के साथ, or maybe there is one topic we have the demo of the random access file that I promised that I will do it in the demo session in future. Okay, till then, खुदा हाफिज़, अल्लाह निगहबान.